All right, so you made it to my video for reviewing for the Accuplacer college level math test. Hopefully this turns out to be a good video. This is my third attempt this morning at making a video. The first two attempts, I haven't got through the introduction yet, and I keep stopping the recording because I'm just not happy with what I'm saying. So hopefully what I wind up saying now is awesome. If not, I apologize. Anyways, my name's John Grima, and I teach at Glendale Community College North Campus. And Lisa Brown and myself, who is a GCC teacher as well, math teacher, wrote these questions to help you prepare for the college level math Accuplacer test. This summer, I helped a student review for this test using the review that we have on our website, and he went in and took the test, tested into college algebra, which is what he wanted, but he came back and told me that the review that we had nothing to do with the test, and I believed him, but I guess not completely. So I went and took the Accuplacer test myself, and it was true. The review that we had nothing to do with the Accuplacer test, so I decided I'd write another review. And then before I sat down to write this review, I took the Accuplacer test with Lisa a second time, and my second test and my first Accuplacer test felt like two completely different tests, so that when you go to take the test after studying for this, you might get yet a third completely different test. So I did the best I can to write problems to get you thinking in the way Accuplacer wants you to think, but there is a chance that you go through this and it's like, well, this was a waste of my time. But I hope that's not the case after taking the Accuplacer test twice. Hopefully, at least I know the vibe of what they're going to ask. So in a bit here, I'm going to I'm going to do all the problems on my review to help you just kind of get thinking mathematically again, especially if it's been a while since you've done any math. In addition, on the Accuplacer website, they also have a 20-question review, and that 20-question review that they have on their website doesn't have an accompanying video that explains how to solve the problems, but there's a bunch of videos on YouTube that show the step-by-step solutions to their problems. So let me show you where that additional practice test is, because it's free. And if you do my review and the Accuplacer review, and I'd like to think that's enough review, and let me point you to that real quickly. So I did a web search. I just typed in Accuplacer on Google, and I think the Accuplacer website is accuplacer.org. And when I flick over to my computer screen, you'll see what comes up when I went to Accuplacer, and I'll just guide you and point you to where this test is at. Practice test at that. So when I did my Google search for Accuplacer, this is just accuplacer.org, and what I'm going to do now is just click on the tab that says Information for Students. And then up on the top, I'm going to click on the link that says Accuplacer Tests. And then I'm going to click on the link that says College Level Math, which is kind of towards the bottom here. And then when you scroll down, you'll get practice sample questions. The practice sample questions that's going to come up is a practice test for every single imaginable Accuplacer test, and we'll have to scroll down a little bit to find the college math ones. So again, I searched Accuplacer, clicked Information for Students, did the test, and then the college algebra tab, and now I'm at their sample questions, and if I scroll down enough, eventually I'll stumble across. There's elementary algebra. There's college level mathematics. Starts at page page 13 apparently. And there's 20 questions. They're all multiple choice questions. The test that you're going to get at our testing center has multiple choice questions. My test that we're going to do today doesn't have multiple choice questions, but it will definitely help you study, because if you could do the questions when they're not multiple choice, and the idea is you could just click on the right answer. So you should, if you have the time and the desire, go to the Accuplacer website, get this test, and then do it if you can do it by yourself, or search out a video. There's a ton of videos, like I said, and some better than others, probably some better than I ever could do. So you definitely want to, if you're really serious about doing well on the Accuplacer test, do that in addition. All right. Well, I don't know that that's everything I wanted to say, but I'm going to just start, and if I think of anything, I will say it as I do the review. So the idea of how I've written almost every problem except one on this review is that there's a part A and a part B, and the idea would be if you could do the part A without watching the video, you're completely awesome. Do it and then do it. Check your answer, because there's answers provided. And if you had the right answer for, say, you thought you knew how to do 1A, you did it, you checked your answer, it was right. Do the same thing for 1B, because 1B is going to have the exact same skill set as 1A. And then if you know how to do a part A and part B of a specific problem, don't even watch me do the video. If you couldn't do, let's say, problem 1A, then my hope would be you'd watch my video of me solving problem 1A, and then after I get done with 1A and you feel semi-good about it, you pause the video and you move on to part B, because part B is essentially a problem that has the exact same structure and the exact same technique to solve. And you should pause the video, try to do part B of a question, and then hopefully after watching my part A and kind of having that as a template, you can do the part B, and then again, check your answer. If you go through part B and get an answer wrong, then watch my video of how to do it, and then hopefully seeing it twice will make it so you kind of understand it. If you get the part B right, you can just fast forward and not watch my video. It'll make the videos go a little bit quicker, because I kind of babble and maybe say too much, as you're probably finding out now. But anyways, this review is split between two videos that take about probably 2.5 to 3 hours. And if you want to speed up the process, you can fast forward through some of my gibberish that you don't need to see if you understand how to do a problem. All right, so problem 1A, again, if you know how to do it, and go to the end of my review and check your answer. So my goal is to come up with the answer y plus 1 over y minus 3. And so if you can do that without watching me, then you're awesome and you don't need to watch me. If you can't do it and get that answer, then I will show you how I came up with that answer. And so this is an addition problem, and it has fractions. And if I'm going to add a problem with fractions, I have to have common denominators. So I'm rewriting this problem to make myself have room for a common denominator. And not that it's crucial, but it probably helps if I take the denominator of the first fraction and put it in a parentheses. Then I can see that the denominators are essentially identical, except the right fraction has a y minus 3 in its denominator that the left fraction doesn't. And if I, to the left fraction, multiply by y minus 3 over y minus 3, that will cause my two fractions to have exactly the same denominator. Generally, when we're adding or subtracting fractions, We always distribute and clear any multiplying that's in the numerator, but we generally don't FOIL out the denominators. So I should FOIL out or simplify, I'll say distribute to clear the parentheses in the numerator. But don't FOIL the denominator or don't simplify the denominator. So this numerator, the y times y minus 3, that I'm going to simplify it by going y times y and y times minus 3. The y times y is going to give me a y squared, and the y times minus 3 is going to give me a minus 3y. So that will allow me to make the left fraction have y squared minus 3y over y plus 4 times y minus 3, and the second fraction, forgot the plus 4 here, has an 8y plus 4 over a y plus 4 times a y minus 3. Once you get the two fractions to have exactly the same denominator, then you can make the numerators together into one kind of big fraction. And when you're adding or subtracting fractions, they have to have the same denominator, and the denominator doesn't change when you add or subtract. So that's, at least I've added. I haven't done the and simplified part completely. I haven't talked about the where defined part. The where defined part has something to do with the domain of the original problem and the domain of my answer. And saying that my answer equals to the original problem, it's true except where the answer, there's a number that's not in the domain of the answer that's in the domain of the original problem. That's not important, and I don't want to babble and confuse you more, but the where defined part is something that Accuplacer just tossed in there, and it's kind of nice, but it has nothing to do with the solving the problem. It has something to do with saying this is equal to that. But I won't get further with that. So I'm almost done. Now, in the numerator that I've created in my single fraction, they're like terms, and those like terms I'm going to combine. The numbers in front of the y's have opposite signs, so I subtract them and take the sign of the larger. And that takes me to this line, which still doesn't look like my answer. And now I'm to the real important part of the and simplify. I guess I've been and simplifying a bit here, but the big trick to this problem is, in order to get the answer that Accuplacer might like you to have, you're going to have to factor that numerator. And if you don't remember how to factor, in my intermediate algebra, chapter 1, I review a bunch of factoring, but quite honestly, if you completely don't remember how to factor, then college algebra is probably too high of a math to shoot for, because your factoring skills need to be really sharp to go through and do well in college algebra. So I'm just going to factor this. This factors into y plus 4 times y plus 1. And now I can simplify because the y plus 4s are cancelable. And after I cancel, I don't really need the parentheses anymore in the numerator. It wouldn't be wrong to write that as an answer with the parentheses around the y plus 1 and the y minus 3, but the parentheses aren't necessary, and this would be a better answer than the version with the parentheses. And the Accuplacer test is hard, but it's not tricky. Like, you wouldn't see this as an answer and that as an answer. If you get an answer that's has the right variables and numbers in it, then they're not going to confuse you by putting the same answer twice with a different format. So if you got this far, you'd be able to pick that answer out in a multiple choice test all day. Okay, so my hope would be that you could do part B of number 1. Pause the video and try to get the answer of z minus 1 over z plus 2. My writing is not stellar, to say the least. And when I write my z's, I put little lines through them. Otherwise, my z's and my 2's start to look so much alike that I can't even tell them apart half the time. So this is my goal, is to get z minus 1 over z plus 2. And I'm going to get it the same way. So I'm going to take my initial problem and put a parentheses around the z plus 2, and then multiply top and bottom and do my best to get there using the same sort of strategy. Maybe this problem's just a little bit harder, but it shouldn't be that hard. If you understood the first one, this one should follow the same path. So in this problem, both fractions have a z plus 2 in the denominator. The second fraction has a z minus 5 in addition to the z plus 2. So I'm going to put the z plus 2 in a parentheses just to make them look alike, and make my foiling on the next step. Well, I guess no. Just make them look alike. When you're taking the Accuplacer test, because you're not turning in any work, you don't have to show your work as nicely as I'm showing it here. Not that this is that nice. It's just as long as you can get down to an answer, you're good. So first step is I multiply to make the fractions have the same denominator. Second step is I'm going to multiply out that numerator of the left fraction. Notice that when I wrote the right fraction just now, I snuck a 1 in front of the z. That's just because a lot of students don't think of it, and if there's a variable written without a number in front of it, there's an implied 1. Multiplying out the numerator of the left fraction now, z times z is z squared, and z times minus 5 is minus 5z. Now I can make the two fractions into one fraction because they have the same denominator. So I'm going to take the left numerator, z squared minus 5z, plus 5 minus 1z, and put it all over the common denominator of z plus 2 times z minus 5. In the numerator, the things that can be combined are the like terms of minus 5z and minus 1z. And when you combine those into a single z term, because the numbers in front of the z's are both negative, you add the numbers and keep them negative. If it was one positive and one negative, you'd subtract them. But when they have the same signs, you add the numbers. So now I'm going to write this as z squared minus 6z plus 5 over z plus 2 times z minus 5. And just like the last problem, to get from this stage to the answer stage, I have to factor the numerator. And again, if you can't factor, it's possible to relearn factoring. Just go to my website and actually just search for me on the internet. You'll find I should come up pretty quickly, and you'll find my website. Go to the intermediate algebra links and start watching my chapter 1 videos. I do a really extensive review of factoring there. So I'm just going to factor that numerator without really any explanation, and that factors into z minus 1 times z minus 5. And I'm going to cancel the z minus 5's. That makes it so I don't need the parentheses anymore around the z minus 1, nor do I need the parentheses around the z plus 2. And then I'm done. That matches up perfectly with the answer that I wanted to get, so I know I did well. 2 isn't a particularly hard problem, but it's a kind of problem that you may have never seen before. And each time I took the Accuplacer test, there are probably 4 or 5 problems where I had to really think for a minute to figure out, what the heck Accuplacer was asking, and then I realized the problems weren't that hard. And so I tried to, do some things that kind of had the spirit of their problems, and there was something that had this kind of feel to it. Again, it won't be exactly the same, but it will be similar. If you happen to get it, I think I got something like this on both my Accuplacer tests. So when I go to do this, I'm supposed to put a number in for k so that the left and the right side are equal to each other. And when you look at the problem how it's given, it's not terribly obvious what the k is. My hint would be to FOIL the right side, and that's going to make it maybe more obvious what number to replace the k on the left side with, so both sides are equal to each other. And again, this is an odd problem because I generally don't think you ever see something like this, and why would you know to do what I'm about to do? I'm not sure, but hopefully if you get something like this on the Accuplacer test, then at least by doing the 2 problems we're going to do, you can catch their trick, because it's not particularly hard. Most of their problems that are kind of theoretical in nature aren't particularly hard. So if I take the time to FOIL out the right side, I do firsts, x times x, outers, x times minus 3, inners, 7 times x, last 7 times minus 3. I get x squared minus 3x plus 7x minus 21 as the foiling part of the right side. And generally when you FOIL, the outers and the inners combine, and that's true here. And when I combine the outers and the inners, because they have opposite signs, I subtract and take the sign of the larger. This is like 7x minus 3x, which is positive 4x. If you get a problem like this on the Accuplacer test, this trick should work, because it worked both times for me. I simplified the side that didn't have the k, and that made it so like these x squareds are the same, these minus 21s are the same. The only thing that's different is one side has a k in front of the x, the other side has a 4 in front of the x. I suspect the answer has to be that k equals to 4, and it does. Part B is a little trickier because the k comes out to be a negative number. I'll do it, and if you pause the video and do it ahead of me, that's what I'd like for you to do. And if you can't figure out the negative 11, I'll show you. So I'm going to do the same thing for part B. Hopefully you don't even have to watch me do this. I'm going to FOIL out that right side. Again, if like foiling is something you don't remember at all, then again, you're probably shooting a little too high if you're shooting for college algebra. Factoring, foiling are skills that are you just have to have down perfectly to go into college algebra or higher, calculus, trig. So I FOILed the right side. My firsts were x squareds, my outers were minus 5x, my inners were minus 6x, my last were positive 30. And then the outers and the inners are going to combine again. Because the 6 and the 5 have the same sign, I'm going to add those numbers and keep them negative. That's enough for me to know the answer is negative 11. Because both sides have an x squared, both sides have a 30. The only difference is this is a kx, that's a minus 11x. If you needed to, you could have thought of this other right side as x squared plus negative 11x plus 30, because any minus can be replaced with plus a negative. and then it's more in line with the left side, but that's probably a bit overkill because I can kind of figure out that negative 11 is going to be the answer, especially in a multiple choice test. But if you wanted to rewrite it like that, then it's maybe more clear. But for whatever, the answer to this problem is going to be k equal to negative 11. Again, every time I'm doing that, I'm checking to make sure I haven't wrote something down that's not right. There's a bunch, both times that I took the Accuplacer, there were absolute value problems, easy absolute value problems and hard absolute value problems. This I would classify as an easy absolute value problem. Later on, you'll see a hard absolute value problem. So make sure to review the absolute values before you walk into your test because you're probably going to get them. To solve an absolute value that's set up like problem 3, the left side, everything on the left side is under an absolute value and the right side's just some number. You need to create 2 problems. One is just dropping the absolute value and leaving what's left. And the other is dropping the absolute value and finding the opposite or changing the sign of the number to the right of the equal sign. This is because the absolute value of, if this turns out to 16, the absolute value of 16 is 16. If 2x plus 10 simplifies when you plug into x to negative 16, when the absolute value you get positive 16. So this is solving an absolute value equation. You generally expect 2 solutions. The solutions that I'm expecting are 3 and negative 13. And to get my answer of 3 and negative 13, since there's 2 solutions, I had to create 2 problems. And none of these have squares, so I don't have to worry about factoring. The left side, I subtract 10, get 2x equal to 6, divide by 2, get x equal to 3. The other side, I subtract 10. On the left side, the 10s cancel, I have a 2x. On the right side, the 16 and the 10 have the same sign, so I add those and keep them negative. And then I divide by 2. I would suspect that on a problem like this, Accuplacer would not give you a calculator. So they expect you to be able to divide negative 26 by 2 without a calculator. 3b should be the same. So it's going to be the same, but one of the answers is going to be a fraction. That shouldn't make the math that much harder. And again, it just looks a little bit harder when I look at it. But the answer to 3b that I'm shooting for is x equal to 2 and then positive 10/3. So I'm going to do the same thing for part B that I did for part A. I'm going to create 2 problems. One problem that I just dropped the absolute value, and the other problem that I write the opposite of what's to the right of the equal sign. The opposite of positive 2 is negative 2. I'm going to solve each. There's no square, so I don't have to factor. For the left side, I'm going to minus 8. And now, on the left side, the 8's cancel. I'm left with a minus 3x. And on the right side, I have numbers that have opposite signs, so I have to subtract. 2 minus 8 is negative 6. And then I'm going to divide by negative 3, divide by negative 3. The 2 negatives divide out to be a positive, and I get x equal to 2, which is the first answer that I wrote. For the next side, I'm going to go minus 8, minus 8. That gives me minus 3x. Numbers have the same sign, so I add them and keep them negative, equals to minus 10. And then I divide by minus 3, divide by minus 3. The 2 negatives on each side divide to be a positive, and I get the answer of 10/3. And again, this is a multiple choice test, so once you get the numbers, you'll be able to identify them. I'm writing x equals next to my numbers. I think when Accuplacer shows the answers, it just shows the numbers. It doesn't show the x equal, the variable in them. 4 is an easy problem, but it's worded tricky. So this is a system of equations, and we're asked to basically solve the system of equations for y. And usually when you do these problems, you'd get an answer that has both an x and a y. But that's not what Accuplacer wanted, so I'm not going to give you both the x and the y. When I do this, my goal is to have an answer of y equal to -8. It's not particularly hard. What I'm going to do is just add the equations together, because if I add the equations together, the y's are going to drop out. I'm going to think of the x in the first and the bottom equation as having a 1 in front of it. Now when I go 4x plus 1x, I'm going to get 5x. The y's will cancel. 8 and 12 will be 20. Feels so good that I'm going to get an answer for x in like 2 steps. But that answer doesn't belong anywhere because it's not asked for. So the answer is y equal to -8. I have x equal to 4. I need to now actually do what I'm asked to do. I need to solve for y. And to solve for y, I need to pick either equation that was given to me. I like equations that have positives better than equations that have negatives. So I'm going to take the top equation. But if you took the bottom equation, you can get the same -8 for y. And once I decide on an equation, what I need to do is I need to replace the x with 4. That's going to give me 16 plus y equals to 8. And now I'm going to go minus 16 minus 16. That's going to give me y on the left side and -8 on the right side. So again, not a particularly challenging problem. If you haven't seen it in a long time, then it would have been, you wouldn't have known how to start, but a tricky way to ask the question. So hopefully with my stellar explanation, you can handle 4b. 4b wants me to solve for y again. It should be set up the same way. My answer that I'm shooting for is -2. So the answer, at some point, is going to be y equal to -2. So if you got that without me, that's beautiful. You're doing great. If not, you can watch me do this. So I'm going to add the equations together again. Problems can get a lot harder if you've done this. Is called the addition method. Some books call it the elimination method. This method usually involves multiplying one or both rows by a number before you add them together to drop out the variable. But in this case, if I just add the equations together, I get 1x plus 1x is 2x. The y's are opposites, they cancel. And if I add the 8 and 12, I get 20. And then divide by 2 leads me to x equal to 10. And now I need to solve for y, because the question asked me to solve for y. And I like picking an equation that has pluses as opposed to one that has minuses. So I pick the top equation, but the bottom equation will give you the same -2 for y. And what I'm going to do is change the x to 10. And now I'm just going to solve that. There's no squares, so I don't have to worry about factoring. And when I do that, I get y equals -2. All right, problem 5. Again, not a particularly hard question, but most students probably have never seen something called a determinant. And a determinant is a number associated with something called a matrix. The number's not particularly hard to get, but again, if you've never seen this before, there'd be no reason to have any idea what to do with it. So what I'm going to do is I'm going to rewrite the left side without these, which look like absolute value symbols. They're called determinant symbols. And how I drop the symbols is I kind of cross multiply. I cross multiply down, which is 2 times -1, and I cross multiply up, which is x times 5, and I subtract the down minus the up. So that extra minus sign is because you subtract the two products. That's what the left side will simplify to be. The right side could just hang out and stay 8. So I've dropped the determinant signs and created a problem that shouldn't be that hard to solve. This 2 times -1 I could write as -2. I'm going to leave the subtraction sign, and the x times 5 I'm going to write as 5x. So that gives me -2 minus 5x equals to 8. I'm going to add 2 to both sides and get -5x equals to 10. And then divide by -5, divide by -5, and I'll get my answer of x equal to -2. And again, I should check because I have the ability to check because I have an answer key, and I think I said that. 5a, x equal -2. If I do 5b, my goal is to get 4 for an answer. I'm going to do exactly the same way. I'm going to multiply down and get x times 3, which I should probably write as 3x. Multiply up and go -3 times 4. I have to write that second and put my subtraction sign between them. So this is going to give me 3x minus -12 equals to 24. Notice I just instinctively threw that -12 in a parentheses. Generally, when you have two signs, two negative signs next to each other, you throw the second thing in a term number in a parentheses just to separate the signs. The double negative I could change to a positive. And then you minus 12 gives you 3x equals to 12, and then divide by 3, and you get the answer of x equal to 4. The next problem, I just have to do a little bit of explanation before I actually do the problems, which probably drive me nuts, sorry. But there's just some rules for logarithms that if we don't know the rules, then we can't do the work. So this is a quick review of logarithms. There are 3 rules of logarithms between 6a and 6b that we need to remember. My goal is to write the answer log base 2 of x cubed over y to the 4th. It's a single logarithm that's equal to the difference of logarithms. And the first rule of logarithms that I'm going to apply in my attempt to rewrite this problem with 1 log as opposed to 2 logs I call it the product to power rule. I could call it the multiply to exponent rule because it's the same thing. Product and multiply mean the same thing. Power and exponent mean the same thing as well. And abstractly, that rule says this: if I have some number, I'll call it n, times any logarithm, that number can be drug inside the logarithm if you make it an exponent. So a number multiplied by a logarithm can be brought inside the logarithm if you make it an exponent. And that's what I'm going to do for both logarithms. I'm going to apply this rule that says if there's a number multiplied by a logarithm, that number can be drug inside the logarithm without the sign if you make it an exponent. That's the first rule that I need for 6a. The second rule that I need to remember for this problem, and there'll be a third rule for the next problem. I call it the difference to divide rule. Well, our difference could be minus, and divide could be quotient. Usually I call it the difference to quotient rule, and then I say it's also the minus to divide rule, but man, it doesn't matter. And what I call it, what matters is how to use it. And what this rule says, if there's not a number in front of a logarithm, and if there's two logarithms that are being subtracted and their bases are the same, it doesn't matter what the arguments are, I can condense those two logarithms into one logarithm if I form a fraction and put the argument of the left logarithm in the numerator and the right logarithm in the denominator. So I have one more step and I'm going to write my answer. My answer, now I'm going to use the difference to divide rule. I have two logarithms, both base 2 with a subtraction between them. Doesn't matter what the arguments are, but these two logarithms can be condensed to one logarithm as long as I create a fraction and in the numerator put the argument of the left logarithm, and in the denominator put the argument of the right logarithm. And this would be the answer. It should match up with my answer hopefully perfectly. If you're jumping ahead to do 6b, you'll notice my answer for 6b doesn't have a fraction and it needs another rule. So before you watch the video for 6b, if you don't remember, the third rule that we need to remember is the add to multiply rule. And what it basically says is if you have two logarithms that have the same base with a plus sign between the two logarithms, that those two logarithms can be simplified to one logarithm if I multiply the arguments. And that's what we're going to need for part B of this. A little bit later on in the video, we'll have to do these rules backwards. The power to product rule, the divide to difference rule, the multiply to add rule. They go left and right, these rules work. So when I do, hopefully that's all on the screen. Yeah, I think it was. So when I do part B of this, the first thing I'm going to do is my product to power rule, and I'm going to rewrite the first logarithm as a log base 3 of x to the 5th, and I'm going to rewrite the second logarithm, leaving the plus sign in front of it, as a log base 3 of z squared. Now I've got the two logarithms with no coefficients. Now I can use the add to multiply rule because I have two logarithms with a plus sign. The bases are the same. Doesn't matter how simple or complex the arguments are. These two logarithms can be condensed to one as long as I keep the base the same and I multiply the arguments. It might be nice if I would have taken the time to put this in a parentheses, but I didn't on my key. It's not such a big deal. Again, Accuplacer is not that tricky. If you get the answer essentially right, then you'll be fine. For whatever reason, 7 is a tricky problem that's not that hard that I think I saw on the actual Accuplacer review on their website, and I think I got it on one of my two tests. Again, and not a particularly hard problem, but it's hard if you don't know the trick. And quite honestly, how I figured out how to solve this is differently than I'm going to show you, because how I figured it out was way too theoretical. So even understanding this question would be kind of impressive. So it basically says I have a function, f of x equals 2 to the negative x, and for any two numbers, a and b, if a is smaller than b, is the result is f of a less than f of b. The answer is either going to be yes for every a that's smaller than b, f of a is either yes less than f of b, or no, it's greater than f of b. And I don't know that that's even good enough for you to understand it. I understand it because I can read mathematics. so I'll show you the trick. And whether you understand exactly what the question is asking or not, that's okay. You can still get the right answer. It's kind of a heady problem. And then how I solve this problem is using tricks from maybe higher level math that might almost feel illegal. So my goal is to see if f of a is less than f of b. But I don't want to do it for any a and b. I'm going to pick numbers for a and b because this problem is supposed to work for every single number a and b such that a is less than b. So it should work for the numbers that I pick. I have to pick numbers that are easy to work with and that a is smaller than b. I'm going to pick 2 and 3. And so for my f of a, I'm going to do f of 2. And for my f of b, I'm going to do f of 3. Again, this might feel like, why is he doing what he's doing, and how does that lead to an answer? Just stick with me, and by the end, you'll at least understand how to get the answer. You might not understand what the question's asking, and that's not unusual. I know when I was a student, actually went to GCC for my calculus classes, a lot of times I could answer questions and not really understand what the heck I was doing. That happens all the time until, it takes a lot of practice and just taking higher math classes to start understanding everything that you need to understand. So for f of a, which is 2 to the negative a, and this, for my a, it's going to be 2 to the negative 2. So my f of a is going to be 1 over 2 squared, and that's going to be 1/4. My f of b would be 2 to the negative b, but I'm changing b to 3, so that's 2 to the negative 3, and that's going to be 1 over 2 cubed, which is 1/8. The question is f of a less than f of b, yes or no? Well, f of a is 1/4 because f of a came out to be this. So this is asking me, is 1/4 less than f of b, which comes out to be 1/8? And a quarter is bigger than an eighth. If I give me a quarter of a pi, it's better than getting an eighth of a pi. So this is not true. Is f of a less than f of b? The answer is going to be no, because for my two numbers that I used, 1/4 and 1/8, 1/4 is not less than 1/8, 1/4 is greater than 1/8. So my answer is just no. For the next part, it's a little bit easier because you don't have the negative exponent, but the question's the same. So the function is 2 to the x. I need to pick any two numbers for a and b, so I'm going to pick the same. I'm going to let a equal to 2 and b equal to 3. I'm going to do f of a, which would be 2 to the a if a didn't stand for a number, but I'm going to make it 2 squared, which is 4. And then I'm going to do f of b. Abstractly, f of b would be 2 to the b power, but I made b equal to 3. So f of b is going to be 8. And I'm asked yes or no, is f of a less than f of b? Well, f of a is 4, and f of b is 8. Notice I probably should put 2's here, but maybe it was nicer without the numbers. And the question is f of a less than f of b, or is 4 less than 8? And yes, 4 is less than 8, so my answer to part B is going to be yes. For whatever reason, I wrote this, I didn't do a part A and B for number 8. 8 and 9. 8 should be 8A and 9 should be 8B. I have no idea why I did every problem as an A and a B except 8 and 9. And we'll treat 8 as 8A and 9 as 8B. And got this. This is on the Accuplacer review online. It's a tricky problem. So in order to do this problem, I have to pull out some, pretty complex math. Well, theoretically complex math. Not so complex when you watch me do it, but again, why I'm doing what I do is because this is the way I thought to get the answer, and I don't know that there's a better way. It's not a particularly hard question, but if you've never seen this question before, I don't know that any student, even the best Calc 3 student at GCC would have an idea how to do this. What is the largest number of points of intersections between x plus y cubed equals 5 and a quadratic function? Probably if I had not watched this video, I would just make a guess and pick one of the multiple choice answers and move on. But in order to do this problem, in order to get the answer that they're going to want, there's a theorem that I need to remember from or know from college algebra, and the theorem says a polynomial of nth degree has at most n solutions. I think this is a corollary to the fundamental theorem of algebra, but I looked on the internet this morning and I'm not sure that that's what I call it. So this is the theorem that I'm going to use, which means something like this: x cubed plus 5x squared plus 7 equals to 9x. This would have at most 3 solutions, because this is a polynomial because each of the exponents is a nice positive integer, and it's a third degree polynomial because 3 is the highest exponent. Something like this: 2x squared plus 6x to the 4th minus 5 equal to 0 would have at most 4 solutions, because it's a 4th degree polynomial equation. I should say a polynomial equation of nth degree. You need an equal sign in there to have solutions. This probably feels like it has nothing to do with the problem, but it does. It's probably the easiest way to solve the problem. So what I'm going to do is take the little paragraph, transform it into a problem that needs this theorem, and then it'll be easy to answer. So it's a really heady problem, and we'll see what I could do with it to make it tolerable. So I'm not very visual. There may be a way to solve this visually, but I'm asked to take this equation, x plus y cubed equal to 5, and intersect it with a random quadratic equation. A quadratic equation is an equation that has a squared. I'll do them with a nice, lovely x squared. So what I'm going to do is I'm going to take my given equation, and intersect it with a quadratic equation that I make up, or quadratic function that I make up. To be a quadratic function, you have to have a squared term, and the one I'm going to make up is y equal to x squared. And how do I intersect these? Well, you could graph them and intersect them, but I'm not that talented at graphing, and it might not get all the intersection points that I want. To intersect these, what I'm going to do is I'm going to take my equation and I'm going to replace the y in the given problem with x squared. And that's going to transform the problem into something that's going to be ready for this theorem. So I'm going to write this as x plus y cubed equal to 5, but I'm going to replace the y with x squared. And I put a parentheses in just so it didn't look like x to the 23rd power. And now I'm going to multiply the exponents. I get x plus x to the 6th equal to 5. This is quote-unquote intersecting these equations. And from the theorem that I kicked out before, this has at most 6 solutions. And each solution would be an intersection point. So the maximum number of times this equation in a quadratic can intersect is 6. So the answer to my problem in a really bizarre fashion is 6. Again, I don't know, that explanation probably wasn't stellar, but hopefully it was good enough for you to maybe be able to do question 9. And if you see it on the Accuplacer test, maybe you can take a stab at it. Again, you don't need to get 100% on the Accuplacer test, and there are some definitely heady problems. This problem maybe being the headiest problem, because I wouldn't. It took me, when I saw this, a chunk of time to figure out how the heck am I going to do this, and I figured this out. And there's maybe nicer ways to do it, but I couldn't think of another nicer way. So 8 is really like 8A. 9 is kind of my 8B. For whatever reason, I didn't do these as A and B. So now I'm intersecting the same x plus y cubed equal to 5. I'm going to intersect it with a cubic. And the simplest cubic function I can think of, cubic means an exponent of 3, is y equals x cubed. So I can works with any cubic, this theory, and so I'm going to take the equations and intersect them, and I'm going to replace the y in the given equation with x cubed, and then I'm going to pull out the theorem that says if you have one variable raising it to 2 powers, you multiply the exponents. It should be equals to 5. And this equation, because it's a 9th degree polynomial equation, has at most 9 solutions. Which means the largest number of points of intersection between x plus y cubed equal to 5 and any cubic equation is at most 9. Getting close to the end of part 1. I think I just have to do 10 and 11, and then everything else is in part 2 of my videos. So hopefully you can sit through and do them all at once, but if not, I completely understand. 10's a really friendly back down of complexity. Wants me to find a slope of a line passing through the x-intercept w0 and the point 3t. I need to remember the slope formula. To find the slope of a line given 2 points, the formula is m equals y2 minus y1 over x2 minus x1. And if that's too abstract, we'd say the slope can be computed by taking the y-coordinate of the second point minus the y-coordinate of the first point divided by the x-coordinate of the second point minus the x-coordinate of the first point. So in order to get the slope, you have to call one of the points first point and the other point second point. Turns out it doesn't matter what you call first and what you call second. You'll get the same answer if you call the points differently than me, but I'm going to call the first point that's given, and I'm going to call it W0, just to make sense, it's given first, and I'm going to call the second point 3t, and so for my slope, I'm going to use the formula. I'm going to take the y-coordinate of the second point, which is t, minus the y-coordinate of the first point, which is 0, divided by the x-coordinate of the second point, which is 3, minus the x-coordinate of the first point, which is w. And this is going to simplify, but not much. T minus 0 is t minus 0. And 3 minus w, those aren't like terms they can't simplify. That's the slope. So t over 3 minus w is the answer. That's what I'm shooting for there. B is the same. I'm going to use the same formula. Just need to pick a first and a second point. So my first point is going to be the point s comma 0. The second point is going to be the point 2 comma 5. My 5's and my s's look so much alike. That's a 5 here, that's an s there. Sorry, that I don't fix with lines like I do my 2's and my z's. So the slope is going to be y-coordinate of the second point, which is 5, minus y-coordinate of the first point, which is 0, over x-coordinate of the second point, which is 2, minus x-coordinate of the first point, which is s. And that's going to simplify. The numerator, I just get 5 minus 0, which is 5. And the denominator, you can't combine those, are not like terms, so I get 5 over 2 minus s. 5 over 2, stellarly perfect. I think we're to the last two parts of this video. And they're friendly, straightforward one, just dealing with negative exponents. So evaluating a function, just change the variable to the number. So f of 2 for problem 11 is going to be 3 to the 2 minus 3 power. And in the exponent, 2 minus 3 is negative 1, so I get f of 2 equals 3 to the negative 1 power. And when you have negative exponents, you create fractions to make the negative exponent positive. So 3 to the negative 1 is 1 over 3 to the first. And my answer is going to be f of 2 equals to 1/3. Part B, same trick. Find f of negative 5. F of negative 5 equals 2 to the negative 5 plus 2 power. That gives me f of negative 5 equals 2 to the negative 3 power. Make the negative exponent by creating a fraction positive, making f of negative 5 as 1 over 2 cubed. And my answer is going to be f of negative 5 equals to 1/8. So I really hope that I haven't bored you or made things so intimidating that you're afraid to go to the second part. You should really go to the second part and just deal with everything we need to see. So I just did those two and I just checked them. So I stopped checking because I was getting in a hurry to get out of here. 5 over 2 minus s. T over 3 minus s. So I just checked all my answers. But like I was saying, you should definitely watch the next part's about an hour and a half. Take an hour and a half of your time to watch the next part of the video. And if you're feeling more ambitious, go to the Accuplacer website and try their 20 questions. Between my 23 questions, which is really maybe over 40 questions because of the A's and B's, and Accuplacer's 20 questions, you'll have 60 different questions to help you when you take the Accuplacer test, and it's just got to help you out. I really think it would be really well worth your time to try the Accuplacer problems, and try the rest of my problems. Well, thanks for watching.